Indoor sound quality design is an important part of artificial acoustic design. It needs to be carried out under the premise that the background noise is kept low enough in the room, and the noise control will be discussed in the next chapter. The interior sound quality design begins in the earlier stage of artificial design and runs through the interior design and construction stages. Before completion, it needs to go through necessary tests and subjective evaluations to achieve the expected goals through modification. The main buildings with listening functions are concert hall, theater, cinema, multifunctional hall, gymnasium, conference hall, lecture hall, court, large classroom, recording room, studio, etc. Whether the indoor sound quality is good or not depends not only on the performance of the sound source itself and the electroacoustic system, but also on the inherent sound quality conditions in the room. Therefore, for performance venues, whether or not an electroacoustic system is used, sound quality design must be done well, and the application range of the electroacoustic system must be determined before design. The interior sound quality design is ultimately reflected in the interior volume, body size, material selection, and structure design, combined with various functional requirements and artistic processing of the building. The subjective evaluation standard of sound quality includes 5 aspects. The first, appropriate loudness. This is an essential condition for the design of room sound quality, so that people can listen to it without effort or noise. Language sounds require a loudness level of 60 to 70 Fron. Music sounds require a loudness level of 50 to 85 Fron. The second, higher speech intelligibility and clarity. Speech intelligibility refers to the ratio of direct sound and sound energy within 50 milliseconds, following it to the total sound energy. Speech intelligibility is often expressed by syllable intelligibility. The latter is equal to the ratio of number of syllables correctly heard by the listener to the total numbers of syllables uttered. This table shows the relationship between syllable intelligibility and listening perception. Music sounds require the sound clarity. Clarity refers to the logarithm of the ratio of the sound energy of the direct sound and earlier reflected sound arriving within 80 milliseconds to the sound energy arriving after 80 milliseconds. It contains two meanings. One is to be able to clearly identify the timbre of each sound source, and the other is to be able to hear each note clearly. The third, sufficient fullness. This requirement is primary to musical sounds and secondary to speech sounds. It refers to the improvement in the sound quality of the sound source in the indoor compared with the outdoor sound. The first, good sense of space, refers to the indoor sound field, provides the listener with a sense of sound propagation in the indoor space. Its meaning includes the listener's judgment of the direction of the sound source is the sense of direction. The judgment of the distance from the sound source is the sense of distance. And the spatial feeling of the indoor sound field is the sense of surround. The fifth, no acoustic defects and noise interference. Acoustic defects refers to the phenomena that interfere with normal hearing and distort the original sound, such as echoes, sound focusing, sound shadows, and flutter echoes. Acoustic deficiency can cause listeners to experience auditory fatigue, boredom, and difficulty concentrating. Short speech sounds are more prone to echoes than musical sounds. The intrusion of noise has a damaging effect on the indoor sound quality. Continuous noise can mask speech and music, and intermittent noise can disrupt and quiet atmosphere of the room or the sound recording. The sound quality design needs to adopt objective physical indicators related to the subjective evaluation of sound quality, mainly including sound pressure level, reverberation time, time and space distribution of reflected sound. The sound pressure level corresponds to the loudness level. The reverberation time corresponds to the reverberation and fullness of the room. Longer reverb times have longer reverberation and high fullness. The frequency characteristic of the reverberation time is closely related to the subjective evaluation index. To avoid table distortion, the reverberation time for each frequency should be as close as possible. Long low-frequency reverberation time will make people feel warm. High-frequency reverberation time will make people feel gorgeous and bright. However, in different halls or different positions of a hall, the reverberation time is same or close. The subjective evaluation of sound quality is often quite different, and the space feels different. It shows that the reverberation time cannot fully reflect all the physical characteristics related to the sound quality of the room, because the reverberation time adopts the assumption of a diffuse sound field, which is inconsistent with the actual room sound field. Actually, only the reverberation sound conforms to the assumption of diffuse sound field. Before entering the reverberation sound stage, only the direct sound and earlier reflection sound arrive, and the sound field is not diffuse. Because in different halls or different positions of a hall, the energy and time and space composition of the direct sound and the earlier reflected sound are different, resulting in different subjective feeling of sound quality. The reflected sound arriving within 35 to 50 milliseconds after the direct sound is the earlier reflected sound, which can strengthen the direct sound, improve the loudness and intelligibility, and can be relaxed to 80 milliseconds for music. Reverberation is the opposite of earlier reflections. In that earlier syllables mask later syllables, reducing intelligibility. The fullness of musical sounds requires sufficient reverberation, which is not good for intelligibility but helps to beautify the sound quality of the music. The earlier reflections are not only good for clarity, but also important for fullness, enhancing the sense of dynamic and making the direct sound continuous with the reverberation sound. One of the main reasons why some larger halls have enough reverberation time, but not enough fullness, is lack of earlier reflections. The reflected sound arriving within 20 to 35 milliseconds after the direct sound can provide intermercy. For small halls, it is the time interval between the direct sound and the first reflected sound, which does not need to be considered in design. For large halls, it is necessary to design a special reflecting surface to obtain it. An echogram is a sequence of reflected sound obtained by pulse measurement, which can predict whether an echo will appear. Whether the reflected sound will form an echo or not depends on the time difference and the relative intensity of the reflected sound and the direct sound. The reverberation sound can be regarded as radium incidence, but the earlier reflection sound has a certain direction, which is closely related to the shape and proportion of the room. Earlier reflections from the front enhance intimacy. Earlier reflections from the side create a sense of surround. In the earlier reflection sound, the sound energy of the side reflection accounts for a large proportion, and it also reaches the audience earlier than the front reflection in time. The main indicators related to lateral reflexes are room response RR and the interaural correlation coefficient IACC. Room response is an indicator of lateral reflection. The first term of the numerator is the earlier side reflected sound energy. The sound term is the reverberation sound energy, and the denominator is the sum of direct sound and the earlier reflected sound energy in all directions. The larger the RR, the stronger the surrounding feeling. It shows that the sense of surround is not only related to the side reflected sound energy, but also the sound energy of reverberation contributes to the sense of surround. Since the side-reflected sound signals received by the two ears are quite different from the direct sound and the earlier reflected sound signals from the front, the degrees of correlation between the signals received by the listener's two ears can be used to characterize the sense of surround caused by the side reflection. The smaller the IACC, the stronger the surrounding feeling. According to the subjective evaluation criteria mentioned above, you can try to do a questionnaire survey on the indoor sound quality of the surrounding buildings and find the reasons for the room that are not clear.